Hello. Hello, everyone. We're going to start our second lot of talks, and then we've got lunch as the next break. So, Michal, I've been practicing. Yes, Michal from Software Mansion, who very kindly sponsored the event. They've been doing a load of cool stuff when it comes to WebRTC / media in general. I went and spoke at their event, RTC On, last year, and I loved it. And so they are coming and doing the same at CommCon this year. So I will let you get on with it and say welcome, Michal.
Thank you. Thank you, Don, for introducing me. Hello, everyone. My name is Michal. I'm a software engineer at Software Mansion, where I mostly work on WebRTC. And my presentation will be about Elixir WebRTC. This will be a small recap of what we were able to achieve over the first year of its development. So I assume that most of you are familiar with Pion, which is an open source WebRTC implementation written in Go. The phenomenon of Pion is that it made creating WebRTC-based apps much easier than this was before. And Elixir WebRTC is our attempt to create a similar project, but for the Elixir ecosystem. The question is, why Elixir? Elixir is a very high-level functional programming language that runs on top of Erlang virtual machine. And Erlang virtual machine was developed by Ericsson to run software on telecom switches. So both Erlang and Elixir come with a lot of nice features that make programming network and multimedia-related software very easy and convenient. Everything starts with processes. A process is a very lightweight unit of execution. And we can spawn millions of such processes. They are completely isolated from each other, and they communicate using message passing. Hence, no shared state, no mutexes, no semaphores. Those processes can be spawned under so-called supervisors, which are responsible for restarting your process when it crashes, according to the predefined restart strategy. Here, for example, we have one-for-all strategy, so when one of our processes crashes, all of them will be restarted. The next feature is built-in distribution. It allows us to connect two or more Erlang virtual machine instances referred to as nodes in a cluster. So let's assume that I have node A and node B, and I want to connect them. It is as easy as calling node.connect, and starting from this point, I can execute functions from node A on node B. I can spawn also processes on node B. Just by calling node.spawn, I can create a new process. Here I pass an anonymous function that will be executed in a newly created process. And this function waits for a ping message and then responds with a PONG response. As a result of calling node.spawn, I get a process identifier, which I can then use to send a message. And when we call flash function, we can see that we received a PONG response. And last but not least, we have support for pattern matching. Here we have multiple clauses of the same parse function. The first clause will match when the two first bits of our binary will be equal to 0. The second clause will match when the first bit is equal to 0, and the second bit is equal to 1, and so on and so on. Other than that, there is a lot going on in the ecosystem itself. I will just mention a couple of libraries and frameworks. So if you are interested, you can examine them on yourself. So first of all, we have Membrane Framework, which is a framework created at Software Mansion. So that's a multimedia framework. We at Software Mansion run a couple of projects in Elixir, including multimedia software. So that's also a reason why we picked Elixir for implementing WebRTC. Next, we have Phoenix Web Framework, something like Ruby on Rails, but in Elixir. We have also Livebook, which is, you can think about it as Jupyter notebooks, but a little bit more collaborative and interactive. Elixir Next, a set of machine learning libraries. Phoenix Flame, something like application as a function, and ongoing work on static types. So there is a lot going on in the system. And the goals that we adopted at the beginning of our journey, so we wanted to broaden Elixir ecosystem capabilities. We wanted to provide people who already have their applications written in pure Elixir or Phoenix web framework with WebRTC implementation and see what they will be able to come up with. Because of that, we needed very easy Phoenix integration. We also wanted to learn and understand every single protocol that WebRTC consists of. In particular, design decisions that stay behind WebRTC API, why it looks the way it does. And last but not least, API that matches the specification. We started our work on WebRTC about 4 years ago. And I believe that we did a couple of mistakes. One of the biggest one, I think, is that we didn't match the standard at the beginning. So it was very hard for other people to jump into the project and start contributing. How it started? So I started Elixir WebRTC as a side project, mostly by working on stand and turn implementations, and then after some time, on the 26th of June 2023, we have moved the whole concept under software mention, and Łukasz Wala, who is also present here at CommCon, joined me, and from that time we are continuing the project together. For the first 2.5 months, we were improving our stand and turn libraries, implementing ICE, RTP, and RTCP. Then somewhere in September, we created the first commit in WebRTC repository, which holds our peer connection implementation, and today is the 6th of June 2024. And we are at CommCon. The question is, what is the current status of the library? Can I actually build something useful with Elixir WebRTC? And I'm happy to say that I believe that yes. 3 weeks ago, we released version 0.2. Actually, starting from version 0.1, you were provided with peer connection implementation. But in version 0.2, we added a couple of nice features that make it possible to implement or move from POC projects to more production-ready projects, I would say. But starting from beginning, when we take a look at this very popular diagram presenting WebRTC protocols, we implement, except data channels and SCTP, all of them right now. Data channels, I mark them with yellow color as they are on our roadmap, but not for the newest release. And speaking about every single protocol, let's start with ICE. So I will just list features that we support right now, so people who are familiar will know what they can expect from the implementation. We implemented full UDP mode. We also support MDNS candidates, remote MDNS candidates. We do not generate our own ones. We support both aggressive and regular nomination, keep alives, row conflict resolution, all types of candidates, and transaction pacing. So that's our current ICE status. In case of RTP and RTCP, there is support for both inbound and outbound retransmissions. TWCC, here we only generate reports so that browser can estimate more than 300 kilobits per second. We also parse incoming reports, but we do not estimate bandwidth on our own right now. There is support for keyframe requests, sender and receiver reports, MID and audio level header extensions, and Opus and VP8 payloaders and depayloaders so that you can save to file and read from file and send to, for example, web browser. In peer connection, you can add and replace, remove tracks, add and stop transceivers, renegotiate the connection. We support a lot of different types of events. Inbound simulcast, this is actually in progress, but almost merged, and GetStats API, and a couple of more minor features. Yep, so that's the current status of the library itself. But besides it, we also wanted to, let's say, make it a little easier for other people, especially Elixir folks, to jump into the WebRTC world. Hence, we wanted to add a couple of demos, example applications, learning resources, and so on. So let's take a look on what else do we have right now. First of all, two demo applications, Rico and Broadcaster. In case of Rico, this is a very simple application, so I'm not going to show it right now, but it just shows how you can combine Phoenix Framework, Elixir WebRTC, and Elixir NX. We just take the input from your web camera, send it to the backend, then we perform some very simple image recognition and send the result back to the browser. Instead, I would like to focus a little bit more on Broadcaster, which is our web server. So the work on Broadcaster was started by a creator or maintainer of Broadcast Box, which is a similar, I believe, similar product, but written in Go. It's based on Python. So when it was pretty hard in our first implementation for other people to jump into the project, I believe that in this project we fixed that. So let's take a look at Broadcaster. We did a small modification. So you, of course, can stream using OBS to the Broadcaster, but OBS has a small problem that it uses libdata channel as its WebRTC implementation under the hood. And libdata channel, this library lacks a couple of features. For example, retransmissions are not sent on a separate RTP stream. And there were some problems with video freezing. And I believe that there is also no simulcast support right now. So instead of streaming directly from OBS, you can create a scene in OBS, export it as a virtual camera, then grab this camera in your web browser and stream from a web browser. So this way we can combine features of OBS with libWebRTC implementation in our web browser. And because of that, we created a very simple stream panel in our Broadcaster. So you can here select for audio input and video input. If there is virtual camera, OBS virtual camera, you can select it. And you can also pass a server configuration and just start streaming. So once we start streaming, we can, of course, go to the other tab. And we will see the stream. So that's not a rocket science, I think, but it works as expected. Yeah, so that's the Broadcaster. And the next thing I would like to show is Elixir WebRTC dashboard. So Broadcaster is based on Phoenix Web Framework, and every Phoenix application comes with built-in dashboard. So this dashboard is by default located under /dev/dashboard. We have moved it under /admin/dashboard. And it comes with very useful statistics about your Erlang virtual machine and Phoenix framework. For example, here we have metrics that present some information about your HTTP requests. If I, for example, refresh this page a couple of times, where some C plots being displayed, there is the processes tab, where we can inspect every single process that runs on our virtual machine. For example, here is one of the peer connections. We can see what is the current stack trace, so also the function that is currently being executed. We can see message queue, how many messages are waiting to be processed. And there is also information about memory being used somewhere here, and so on and so on. And what is important is that this dashboard is extensible, so we can create our own tabs. And we created an extension that allows you to inspect and visualize metrics and statistics about Elixir WebRTC. So let's take a look at how we can enable it. It's pretty simple, just 2 lines of code. So I'm going to stop the server right now. And let's go to our dependencies. Here we just need to enable X WebRTC dashboard dependency. And in our router where we handle HTTP requests, we just need to add an additional page to the built-in dashboard. And after this, I'm going to restart the server. Okay, perfect. And after restarting, we'll see that there is a new tab called Elixir WebRTC, and it is waiting for new peer connections to be spawned. So let's rerun this transmission. And once we run this transmission, our dashboard will automatically detect a newly spawned peer connection and print and visualize some statistics about it. So we basically do something like WebRTC internals does, but for the server side of things. So there are local certificates, remote certificates, SDP offer answer, some candidates, plots, and so on and so on. If we create or join with some viewers, let's join with a couple of them. We'll see all of them in our dashboard. So just by adding 2 lines of code, we can inspect every single peer connection that runs on the backend side. So that's our broadcaster. And besides this, we also have REL, which is a standalone UDP turn server. We exposed one instance of it. So if you want to try it out or experiment with it, there is a very simple post request that you can execute. It's located in our repository. You will just be provided with credentials, and you can start playing with it. And there is also mastering transceivers guide. I mentioned that we wanted to dive into the WebRTC API, and at the beginning it was pretty hard to understand why the API looks the way it does. But we were spending more and more time and learning more and more. And at the end, we created a very simple guide that shows you everything that you can achieve with transceivers API. So let's take a quick peek into it. So this guide, we just collect a couple of examples showing what you can achieve. For example, what is a warm-up technique, how to establish bidirectional connection using a single negotiation, how to reject incoming track in WebRTC, and so on and so on. For every single example, we include a JavaScript fiddle and a counterpart in Elixir, so that you can see how the API maps to how JavaScript API maps to the Elixir API. Okay, let's go back to the presentation. So that's everything that we were able to achieve over the first year of Elixir WebRTC development. When it comes to future plans, we would like to move to production. So we actually used Broadcaster to stream one of our events called Elixir Community Krakow Meetup, and I hope that we'll be able to stream more of them. We are also going to use this implementation in our fish jump, previously called Jellyfish Media Server. And we are also looking for more opportunities. We would like to add support for bandwidth estimation, and of course extend our dashboard with more metrics. Probably add more concurrency. Right now, our peer connection uses just 3 Elixir processes under the hood, so there is for sure an area for optimization, support for AV1, and of course data channels. So that's everything that I have prepared regarding Elixir WebRTC, and also Dan allowed me to, and also Dan mentioned it already. So I would like to announce that we are also organizing RTCon, which is a conference related to real-time communication and AI. It will be this September. So we would be very happy if you would like to join us. We also prepared a small QR code with a discount. And we are also going to run a couple of workshops. One of them will be about WebRTC. So I hope that we'll be able to share a lot of everything that we were able to learn throughout the process of implementing Elixir WebRTC. Thank you very much. That's everything from me. If there are any questions, I will be happy to answer them.